We already learned how to find the vertex of a parabola, the axis of symmetry, and whether or not there's a max or a min. And today, we're going to find the zeros of a quadratic function. Zeros are where a parabola crosses the x-axis. In order to figure out where the zeros are by factoring, you have to make sure that your equation is set equal to 0. So you're used to seeing maybe y equals or f of x equals our standard form, ax squared plus bx plus c. So all we're going to do is make sure that everything's on the same side of the equal sign, and we'll set it equal to 0. And that's how we find the zeros. So there's 3 possibilities for how a parabola could cross the x-axis. It could cross the x-axis twice. That would be a parabola that looks like that. That would be one time, and that would be a second time. A parabola could cross just one time, and that would look like if the parabola was sitting on the x-axis like that, or maybe if it was hanging on to the x-axis like that. Or you might have no real zeros. This is where your parabola doesn't cross the x-axis at all, which means it's floating up above or it's floating down below. So those are the 3 possibilities. We're either going to get 2 answers, 1 answer, or no answers for real zeros. One of the ways to solve for the zeros is by factoring, and so we're going to pick up with this example with things that have already been factored. So what we do is we take each of the 2 factors and we set them each equal to 0. So we write x minus 3 equals 0, and we write x plus 7 equals 0. And then we solve each of those for x, and we'll have our answer. So in this case, it would cross the x-axis at 3, and it would cross the x-axis at -7. When we have just an x inside the parentheses for a factor, that just means that one of the factors is 0, and the other factor, once we set it equal to 0 and solve, will be +5. So this parabola would go through the x-axis through 0 and through +5. If you've caught on to this, you basically can just flip the sign that you see inside the parentheses. So if it's x plus 4, the answer will be x equals -4. And in this case, we got 2 of the same answer. If you ever get 2 of the same answer, you only need to write the answer one time, because this would be an example where the parabola would be hanging onto the graph or sitting on the graph like that. It would just have one real zero, and you call it a double root. Double root, but it's only in one place. So for these examples, we're going to do everything, including the factoring, by ourselves, and then we'll sketch a quick graph. We just have to make sure that the equations are set equal to 0 before we start. So this one's set equal to 0. We're good to go. We can factor it. So I know we're going to have 2 factors. X times x will give us x squared. And we need to find the factors of 10 that add up to +7. So here are the factors of 10. 2 and 5 will do the trick. +2 and +5. So we have the 2 factors. Next, we're going to set each of them equal to 0 and solve. So we have -2 for one 0. And we have -5 for the other 0. And for our sketch of the graph, I'm going to go to the x-axis, go to -2 and put a dot. Go to -5 and put a dot, and now I'll draw the parabola right through those. I know since my leading coefficient, the a, is +1, it's going to open up, so I'll draw the parabola open up. For today's lesson, we're not going to be concerned where the vertex is, so you can make it dip down as low as you want. It doesn't matter for this lesson. Eventually, we'll put everything together. But for today, what I'm concerned about is you're drawing a parabola through the correct places on the x-axis. Before we start B, we need to make sure it's set equal to 0, and it's not. It's set equal to +8. So how do we get rid of a +8 on that side? Well, we need to -8. So we'll minus 8 from both sides, and that will leave us with x squared plus 2x minus 8 equals 0. Now that everything's on the one side of the equal sign, and it's set equal to 0, now we can factor it. So this will be x times x, give us x squared. Next, we have to find the factors of 8, and they have to subtract to give us positive 2. So we need the difference to be positive 2. 2 and 4 will work. If we do 2 minus 4, that's going to be negative 2. If we do 4 minus 2, that will be positive 2. So I'll put a positive 4 in one set of parentheses, and I'll put a minus 2 in the other set. It would not matter if I put the minus 2 first and the plus 4 after. We're going to keep going and set each of those equal to 0 and get where our zeros are. We have a 0 at negative 4, and we have a 0 at positive 2. So this is a pretty wide parabola. Like I said, you can make it dip down as low as you would like because today we're not figuring out the vertex, and I'm looking for a parabola through that dot and that dot. Make your dots clear because that's what I'm looking for. 2C, we're going to check in class tomorrow, so go ahead and do that. For this example, we have it set equal to 0, so we could try to make our two factors and put an x in one and an x in the other. However, we do not have a c. C is the number at the very end, and it's not there. So it's 0. We'd essentially be trying to figure out the factors of 0 that add up to 3. And that's not really possible because the only factors of 0 are 0 and 0. However, 0 times 3 is 0, and 0 plus 3 is 3. So we can put a plus 0 and a plus 3, and then we'll have our answer. For the zeros, if x plus 0 equals 0, then obviously x equals 0 is one of the answers. And the other answer will be x equals negative 3. So then we'll go to negative 3, and we'll put the parabola through those two dots. That wasn't the only way to solve that problem. If you only have two terms, you can look for a GCF, because in this case we did have a GCF. We can divide both the x squared and the 3x by x. If we were to do that and write the GCF out front and write the leftovers in parentheses next to it, we'd be left with x and plus 3. If we did that, we'd come out with the same answer, that x equals 0 and x equals negative 3. That's what I'm going to do for 2e. It is set equal to 0, but notice this first number is not a 1. So that's a sign that we need to look for a GCF. So what can we divide both 2x squared and 12x by? Well, we can divide them both by 2, and we can divide them both by x. So I'll put that GCF out front, and I'll write the leftovers next to it. 2 divided by 2 cancels out, and x squared divided by x is x. 12 divided by 2 is 6, and x divided by x cancels out. So these are the two factors. When we set 2x equal to 0 and solve, we get 0 for one root. And when we set x plus 6 equal to 0, we get x equals negative 6. So there's the other 0. And there's the parabola. Either way you decide to do it is fine. You'll come up with the same answer either way. For 2f, make sure you get it set equal to 0 before you start. Last, a story problem. We have a dolphin jumping out of the water. When that happens, it sort of looks like an upside down parabola, right? The dolphin jumps out of the water and then comes back down in the water. So the model is this quadratic function right here. And it says it models the height after x seconds have gone by. So our time in seconds is the x-axis, and the height is the y-axis. they're asking how long is the dolphin out of the water. So we're trying to figure out x. How long is the dolphin out of the water before it returns back to the water? So if we find the x's, if we solve this for the roots, then we will get our answer. So we have negative 16x squared plus 32x. My advice, since the leading coefficient is not 1, it is set equal to 0, everything's on the same side, so we can go ahead with this. 32x, is look for a GCF. What can we divide both negative 16 and 32 by? Well, we can divide them both by 16 and x. And I haven't taught you this yet, but if you ever have a negative in front, always pull that out with your GCF. So our GCF is negative 16x. The leftovers will be positive 1 in x. And then 32 divided by negative 16 is negative 2. And the x's cancel out. So we'll set negative 16x equal to 0. And we get x equals 0. That means at 0 seconds, the dolphin is not out of the water, 0 height. And we'll set x minus 2 equal to 0. So that means the other root is positive 2. And this parabola, since the leading coefficient's negative, is upside down. So it's like the path the dolphin takes out of the water. So here he is jumping out of the water. He's out of the water. And then right there, he hits the water again and he's back under the water. So to answer the question, the dolphin is out of the water for 2 seconds.